Welcome to Chapter 15, Part 2, Thinking about Inference. How confidence intervals behave. Now, we've talked about what the margin of error is. The margin of error is your critical value times your standard error of your sampling distribution of the sample mean. Because you're going to have a sample of a certain size, which puts you in a sampling distribution. Now, the margin of error is what gives our confidence intervals its width. So, as the margin of error gets smaller, that results in a more accurate inference because our confidence interval width gets smaller. Now, how can we make our margin of error more accurate? Well, as you can see from the calculation of margin of error, if n gets larger, which means we divide by a larger number, our overall number becomes smaller. So one way we can get a more accurate inference is to make our n larger. Another way is to make our critical value smaller. The way you make your critical value smaller is to make your confidence level smaller. Because remember, the different values for our critical values for the different confidence levels. For a 90%, it was 1.645. For a 95% confidence interval, our critical value was 1.96. And for the 99, it was 2.575. So as our confidence level got greater, so did our value for our critical value. And as you can see, if that gets larger, that would make our margin of error larger. So what we'd like to do if we want to make our margin of error smaller is to decrease our confidence level. Well, that would be one way. So we're going to look at an example of the NAEP quantitative scores that we saw in Chapter 14. We're going to look at the 95% confidence interval and the 90% confidence interval. And we'll see the difference in lengths of the confidence intervals between those two. So for the 95, we go from 267.9 to 276.1. With the 90% confidence interval, we go from 268.5 to 275.5, which is smaller than the 95% confidence interval. So we can actually empirically see how much smaller or more narrow the 90% confidence interval is than the 95% confidence interval. Again, this is a rule itself. Now, cautions about the confidence interval. The margin of error doesn't cover all errors. The margin of error only covers the error due to random sampling errors. No other source of variation or bias in the sample data influence the sampling distribution. Practical difficulties will be things like undercoverage and non-response. They're more serious than random sampling errors. And the margin of error doesn't take those difficulties into account. So be aware of these points when you read any study. Because if they got a sample erroneously or sloppy, the confidence interval they get may be, again, unreliable. Now let's take a look at significance tests. How small a p-value is convincing. Now, if our null hypothesis represents an assumption that people have believed in for years, there has to be strong evidence in order for us to reject that null hypothesis, which means a small p-value. That will be needed to persuade others to reject that null hypothesis in favor of an alternative. If the consequences of rejecting that null hypothesis are great, such as making an expensive or a difficult change from one procedure or a type of a product to another, then strong evidence as to the benefits of the change will be required. Again, another small p-value. Now, a significance level that's commonly used is 0.05, and it is our common cutoff for the p-value. However, there's no set border between significant and insignificant, only increasingly strong evidence against the null in favor of the alternative. So as our p-value gets smaller, that gives us increasing evidence to go in favor of the alternative hypothesis. The p-value for a one-sided test is 1/2 the p-value for two-sided tests of the same null hypothesis based on the same data. So the evidence against the null is stronger when the alternative is one-sided. But use a one-sided test if you know the time you should use a one-sided test is if you know the direction of possible deviations from the alternative. Otherwise, you have to use the two-sided alternative. Now, there is a difference also between statistical significance and the practical significance. When a sample size is very large, tiny deviations from the null with little practical consequences will be statistically significant. When the sample size is very small, large deviations from the null of great practical importance might be undetected. They'll be called statistically insignificant. So statistical significance is not the same thing as practical significance. So this is just, let's look at an example as to what we mean by practical significance versus statistical significance. It's important not to confuse the confidence with which the null hypothesis can be rejected with the size of the effect. So here, to make this point, I got this particular example off the internet, and it was a good one. So here we go. Consider a researcher assigned the task of determining whether the video display used by travel agents for booking airline reservations should be in color and black and white. Now, color monitors, remember, are more expensive than black and white. So if we prove statistical significance, we might have to plunk a lot of money to get colored monitors. So we have to make sure that although it's statistically significant, is it practically significant? And that's what this particular example will show us. So, market research had shown that travel agencies were primarily concerned with the speed with which reservations can be made. Therefore, the question was whether color displays allow travel agents to book reservations faster. Market research had also shown that in order to justify a higher price for colored displays, they must be faster by average of at least 10 seconds per transaction. So they took 50 subjects with color displays and 50 subjects that used black and white displays. And they randomly assigned agents to which one. Now, subjects were slightly faster at making reservation on the color display. In fact, they made a reservation in 504.7 seconds. And then the black and white display, 508.2 seconds. Now, although the difference is small, it was statistically significant at a 0.05 significance level. But practically, that less than 4 seconds that you have an advantage on, was that practically significant? Well, they had already determined that it had to be at least 10 seconds per transaction. So although statistically significant, yes, color monitors did show that a travel agent could make reservations faster. Practically speaking, it wasn't fast enough to justify paying for color monitors, so it was not practically significant. And that's what they mean, the difference between statistical and practical significance. It can be statistically significant, but does that significance relate in a practical way, like will we do anything about it? Please make sure that you look at the other examples on the PowerPoints about practical and statistical significance.